Hello, my name is Rob Reynolds. Welcome to Calculus section 4.1. Today we get the introduction of how to determine a max or a min on a function. And if you haven't already gone to Blackboard and downloaded the PDF file where you can follow along on this video, I would encourage you to do so. Plus there'll be extra problems at the end that I won't get to at the video that I would encourage you to work out. And of course, all worked out solutions are posted on Blackboard for your convenience. All right, so the first thing I need to discuss is the difference between a relative min and a max, an absolute. I circled max. Relative max, relative means it's relative to some interval. Maybe I'm between, well, let's not even call it A and B. Let's just call it between, I don't know, -5 and 0. There might be a relative max. And so you're looking at this function as a whole and say relative to this interval in between here, there's a relative max. But the absolute max of this function would be infinity. Or you would say that there is no max, which I think they do in section 4.1, and then they change the definition in 4.2, 4.3. So again, relative max is just relative to some interval. So here's a relative max. Of course, here's a relative min. Again, I don't know what the interval is, but relative to 2 points, maybe 0 and 10, there might be more than one, a relative min. So then you would want to narrow the interval. So sure enough, just as I suspected in section 4.1, they don't say the max is infinity. They just say there is no absolute max. But this has an absolute min, meaning this is the lowest value in the interval. That's the lowest y value over all values of x. Down over here, we do have an absolute min because it's a closed dot, and we have an absolute max because it's a closed dot. But if they have an open dot, there is no, because, well, it approaches 4. It's not ever equal to the 4, and likewise open dot. So no max, no absolute min for open dots. Oh, well, this one was, yes, it's closed, so there is an absolute max for this one, but here there's no. Again, more examples of no, and this does have a min, and this is no absolute max, some value of y, because we don't know what it approaches here, but I do have a min value, whatever this would be, maybe a 1. So the first theorem that we get is the extreme value theorem, which says if it's continuous, we are going to find, over some interval, we're gonna find a max and a min. It's got to have a max and a min. And to test for that, well, you just plug in your endpoints. Let's see if I can do that. And any kind of critical values, which we'll discuss in a moment. And then you just run your test. You go find out what those y values are for your endpoints and your critical values, and then you just literally just look at the highest y value and then the lowest y value for max and min. But remember, this definition only works for continuous functions, and if it's not continuous, then, well, I can't apply the extreme value theorem. So you can read through some of this more. Great slide, read it. And again, same thing, local max, relative and local mean the same thing. There's two different terminology. But absolute is the lowest, absolutely the lowest y value. So here we go, example. Well, let's back up. For where was example 1? It's important, here we go, example 1. It's important to note we have an absolute max at A. That's the highest value, but it's of this y value, which we don't know. But let's call it 7 right here. So there's a difference between the max at an x value, but if they say what's the maximum of, I have a maximum of the y value. So make sure so over here, I would say the minimum is there's none, and then the maximum looks like it exists, but it's at point when x is c. So now let's go back to example number 2. Again, I've got a closed interval, so I should be able to find an absolute max and an absolute min. And the maximums are at Q and S. And guess what? Those absolutes, since they aren't endpoints, are also the locals. So I think I have the same answer for both. So these are my maxes, but because they're not the endpoints, then the absolutes are the same as the locals. Let's look at here. I've got an absolute minimum, looks like, of P. But then I have several local mins, which you probably include P again because it is a local. It's local between this as long as it's so local cannot be an endpoint. Local needs to be within an interval. Now, absolute can be an endpoint, but it also could be a local in an interval. So I think we've got R, P, and looks like B. Well, wait a minute, it can't be B because that's the endpoint. And locally, I just gave you the definition. So we better back up. I think we're just going for R. And so do you understand why this can't be a local? Because there's no interval. So the endpoints can't be local. So let's see if the author agrees. R, there it is, minimum at R and P. Good. They did not, the author didn't include B either. Okay, so they did say the function does not have extremes at any of the endpoints, which means, if the function would have looked like this, then I would have an absolute, this at point A would be an absolute max. And they're just saying that didn't happen up here in this function. The absolute max was also the local max. So I mentioned critical values before, and a critical point is defined as two things, where you take the derivative and set it equal to 0, and also where the first derivative is undefined. So if the first derivative is undefined, like for example, if you find that the first derivative is equal to 5 over x minus 3, you would say, well, wait a minute, there's a critical value here at x equals 3 because you can't let x be 3. So that would be critical. And anytime that this thing equaled 0, that would also be critical, which I don't think that particular function does. So to say, now be really careful, just because you find a critical value, that doesn't necessarily guarantee that you have a max or a min there. So you've got to run what we're going to call a test. And again, the test is going to look like f of any endpoints, and then f of any critical value, which is setting the first derivative equal to 0 or looking for undefined, and endpoints again, and then just simply testing. Now this test is that's just for 1. This test is going to look different in for 2. When we get there, I'll explain. So let's first of all, let's go find the critical values. So this one doesn't even ask for maxes or mins. It just says critical values. So critical values, just all we have to do is find the derivative and set it equal to 0. So we're going to do 1d2 plus 2d1 and 1d2, the derivative of the second function, plus 2d1, and set that equal to 0. And it might be easier to set this equal to 0 if you could factor out an x. So I think it's okay to pull out at least one x in here. I don't know if anything else can pull out. I don't think so. Looks like there's only one x here. So it's 1 plus the ln, well, is it 2 ln x equals 0. So then either x equals 0 or 1 plus 2 ln x equals 0. let's not write limit, let's write ln of x equals 0. So 2 ln x equals -1. So the ln of x is equal to -1/2. And then to solve, of course, I'll do the fishhook definition, or the definition of a log function, which is b to the y equals x. So e to the -1/2 is an x value. Now, 0 cannot really be critical because it's not really, I can't let, this is the function. We're not talking about the derivative is undefined. We're talking about the function being undefined. So I would throw out 0. I apologize, you hear my dog barking in the background. I'll try to keep him real quiet. So you could either punch this in, or I would just encourage you to leave it, but it's 1 over the square. So then find all the points. Well, of course, points are x and y values. So if you use 1 over the square root of e as the x coordinate, then I'm going to plug it right in here and evaluate f of 1 over the square root of e, and not 3, e, and then let's go see. We get 1 over the square root of e squared times the ln of, can I go back to e to the -1/2? Because that will be easier for me to apply some log properties. So this is 1 over e times 1/2 ln of e, which the ln of e is just 1, so that's just 1 over 2e for the y value. Now, maybe you should have gone decimal. If you just go brain dead and you just punch that in the calculator, you'll get somewhere around 0.61, and I have no idea what that is, but you certainly could punch it in. Oh, good, the author, well, they did for the x. So I like these exact answers because, again, there's a lot of good mathematics in here. Well, you've got log properties, and you're showing me and you're demonstrating your content knowledge of what's the ln of e. And so, yeah, I like these exact answers because then you're showing me the mathematics of it. So again, you're looking for just candidates where the first derivative is equal to 0 or the first derivative does not exist. These are possible maxes and mins. You've got to actually run a test to check to see for sure if it's a max or min. So these are possibilities. Oh, so Mariana was a student of mine in a class, and when I created these slides several years ago, she would always complain that I didn't have enough space on my handouts for her to do the work. So, and that really wasn't the purpose. The purpose was for you to see what we were going to do today. You could take out your own sheet of paper and create more space. But let's go ahead and find the derivative and set it equal to 0 and look for any undefined values. So 4x cubed minus 6x squared. Set that equal to 0. Factor out I can't pull out a 4. So maybe a 2x squared. Leaving me with 2x minus 3. And then set each factor equal to 0. So either this equals 0 when x is 0, or 2x minus 3 equals 0 when, of course, x is 3/2. Again, these are potentials. But these are also potentials. These are called the endpoints, and I need to check the endpoints. So here comes the test. F of -2, f of 0, f of 3/2, and f of 2. Put them in order from left to right. So the test says, okay, go to your calculators, evaluate those for the y values, and I would literally just go to your calculator, plug in for x and solve for y. It's been a while since I've shown you this, so maybe this will be a good refresher. So I just go to your y equals real quick, and I just like to go to your, make sure your table setup is off of auto, go to ask, because we just want to ask for those 4 values, and then under second table, you can just ask it. Where are you at -2, at 3/2, and at 2? And then it gives you those values really quick. So 32, 0, -1.6. Oh, let's go back here. 32, 0, -1. negative 1.6. What was the last one? A 0 again? Yeah. So then I would say, look, I've got a max right here, and I have problems with my pen, of course, and it looks like this is the minimum value. Of course, you could always graph the function and kind of look visually at it too, but that's really not the purpose. Demonstrating your mathematics is the purpose here. So let's try again. Let's go find the derivative by doing the product rule. 1d2. The derivative of 2 minus x is just negative 1. Plus 2 d1. Now the derivative of this guy is 2/3 x, and then 2/3 minus 3/3 is a negative 1/3. I'm going to try to factor out the smallest exponent, negative 1/3, which literally means I'm just going to divide each term by x to the negative 1/3, x to the negative 1/3, and so I have a 2/3 out there. I'm wondering if I could pull out a 2/3 as well. I guess it doesn't really matter. That'll create a fraction here. So I'm just going to do the x. So let's see. This is going to be a negative number, and you rewrite the base, and you subtract the exponents. So 2/3 minus a negative 1/3. Oh, that's pretty nice. That's 2/3 plus 1/3, which is 3/3, or just x. So negative x plus, okay, now this cancels. I'll distribute. So plus 4/3 minus 2/3 x. That's fun. And then I'm going to set it equal to 0. So I think this is your first example where you're actually creating an undefined value. So you can see right here, if you let x equal 0, then the first derivative is undefined, and that's a critical value. So I think I found one critical value at 0. And then if I've done this correctly, let's see, this is 3/3. So negative 5/3 x equals negative 4/3. If I bring this over on the other side, setting equal to 0. And then let's multiply both sides by negative 3/5 and end up with x equals negative 4/5. So if the math is correct, I'm going to run my test, and I'm going to grab the endpoints first because those are critical. So f of negative 1 I'll test, f of 0, f of 4/5, and f of 2. And I'm literally just going to evaluate at all those points. This will turn out to be 3, 0, 1.03, and 0. And then I'll just write and determine. This looks like the max. And it's possible to have 2 mins. We explored that earlier. Let's see. This is part B. So yeah, that makes sense. I have 2 minimums, and it looks like, I don't know, did I have a 0.8? Well, yeah, of course, 4/5 is 80%. So, and then I had the 1 point. Yeah, I had the 1.03. So good. I just had it as 4/5, 1.03. Same. Good. Now, did I find this one? Negative 1, 3? Yes, I did. There's the max. So, and I had 2 mins. Wait a minute. This was a local max. Well, they didn't ask for local. They just said absolute max and minimums. There's nowhere in the directions up here that says find the relatives, but if they did ask you to find a relative, this would be a relative, but they didn't ask that in the directions. So I I would throw that out. They didn't ask for locals. They said, find the absolute maxes and mins. So we're running the test for absolute maxes and mins. And let's use your calculator to guess left, guess right, guess on. Take the derivative, set equal to 0. You'll be okay with that problem. Okay, I think I'll leave the rest of this worksheet for you to kind of work through. I have worked out solutions, but plenty of problems for you to practice. This is the quotient rule, low D high minus high D low. So you can see this all worked out. Find those derivatives, set them equal to 0, go for the critical values, and then the most important thing is just to run that test and make sure you use the endpoints and your critical values to run your test looking for your maxes and your mins, your absolute maxes and mins. 4.1 only talks about absolutes. Good luck.